All right, let's start at the end and kind of work our way backwards. I wasn't here whenever that last time we had school was. So you got the email about the final in quotes. Oh, no, you didn't. Okay, well then it's fresh news to some of you. Maybe you saw it, maybe you didn't. Or it's posted. Anyway, let me try to address it so that we can dispel some of the false rumors that may be floating out there. So we will have a test on whatever day we have the test. I don't know the schedule yet, but whatever day we have it, I will give you a cumulative test. In previous years, it's been the final. Now, this year, it can't count as 20% of the grade. It will only count as a regular test grade for this 9 weeks. So, that's what leads to the confusion of, are we still having a final? Well, I'm going to give you what I normally give as the final, but it doesn't count like a final would count. So, yes, we have a test. Yes, it is cumulative. Yes, it's going to take a while. It's what usually would be a final, but it counts only as a test. It does not count as 20% of your semester grade. The other thing that's really to your benefit is that we will drop one of your test grades for this 9 weeks. That means if you're satisfied with your grade, then you don't have to take that last summative. I don't want to call it a final because it's not a final. You don't have to take that last test whatever day it is. If you don't take it, I'll put a 0 in the grade book, so that might be alarming, but the grade book will drop the lowest grade, so you'll be okay. It's just alarming to see a 0 for test grade, except that you remember that it'll be dropped, so it's not a big deal. So heading into this last week, you may not even know it yet because we got one more test to go, but some of you are probably thinking, wait a minute, my grade's an A, high A, mid A, low A. Well, maybe it's a B and you're satisfied. You're like, I'm good. I don't want to mess with it. Then that is okay. In fact, it's not even the 80 cutoff like it used to be. Like if you're satisfied with your 71, then see you later. I don't know about see you later. I don't know if you have to come that day or not. I don't have that. I don't know if that's been. Good point. Attendance hasn't. You probably can't say that officially on video, but yeah. Why wouldn't you come? Am I going to count you absent? I would count you absent, and that'll be that. Exactly. That'll be that. So, make your decision. You may not need to make it yet because we still have another test to go. But some of you, I'm pretty sure, are already leaning, thinking, if I do okay on this last test, then I'm going to be out, and that's fine. That's how it's designed. So it's, there's lots of ways to phrase it. Are we having a final? Kinda. Do we have exemptions? Not officially like we normally do, but if you're okay with your grade, you can not take the test, so that's kind of an exemption. So when you're talking with friends or other teachers about, the end of course situation, just be careful how you're using the words, because are we having a final? Depends on what you mean by final. We're having a cumulative test, but it doesn't count 20%. Can you exempt it? Kinda, because it'll be dropped. So don't do that unless you're already passing, of course. But you could drop it. So we'll talk more later when we get closer as you start to figure out, I don't want to be here, and I'll figure out how many tests I need to make, because it won't need to be many, I don't imagine. Most of you are doing just fine. Some of you may want to, if you're on an A-B borderline, it wouldn't hurt. Take it and give it a go, and if it helps to get you up to an A or up to a B, great. If it hurts, who cares? I'll throw it out. So you can have that. You can kind of figure that out as we go, but just wanted to address that ahead of time. Oh, one last thing, and this doesn't apply to many of you sitting in here. I don't know if it applies to any of you sitting in here, but for you guys at home, I need everything completed by next Friday, by December 11th. I got to have everything in. If it's not done by then, it's just a 0. It's probably a 0 now, but I'll take late work up until the 11th, because I can't have 14 things come in on this last week and try to get everything done. So the 11th is the drop dead day to turn in all late work. Again, that's if you're at home and you've got missing stuff, and get it in by next Friday. It might be late, but better late than never. All right, now let's back up and talk about our last unit here, sequences and series. Again, open note with calculator, so this is usually not a difficult one. It's about recognizing patterns, and there's some formulas, but you'll have the formulas, so that shouldn't be a big deal. So this is probably not as easy as the last unit, but it's just maybe one step more difficult. So it's not a difficult unit.
Is it going to be a 50-point test again?
That's a good question. Is it going to be a 50-point test again? It's not labeled as such, so I don't think so.
That 50-point test.
All right, let's talk about sequences and series. There we go. All right, sequences and series. They're not exactly the same thing, but they're pretty close to the same thing. And the good news is you can always tell by the context of the problem if it's a sequence or a series. You'll never be explicitly tested on which one it is. So if you use the terms backwards or interchangeably, it's not technically correct, but I don't think there's any place that you would lose any points for that. So a sequence is a set of numbers, like 1, 2, 5, 8. A series is a sum of numbers. So it might even be the same numbers, except instead of just a list of them with a comma separated, it's a sum. So 1 plus 2 plus 5 plus 8. So sequences versus series, not a big deal. Types of sequences. That probably shouldn't be Roman numeral 1 because there's only one Roman numeral. That's bad form. So apologies. But the good news is there's only one Roman numeral today. So types of patterns. Just think of it as recognizing the patterns of what's going on. And there's 3 types, but there's 2 specific types, and then the third type is just kind of the other. So the first type is arithmetic, an arithmetic sequence. Sounds fancy. Here's an example. 4, 7, 10, 13. Even without knowing any vocabulary, I bet you could figure out what goes in the next 2 blanks. Tell me what goes in the next 2 blanks. And 19. It's arithmetic because, well, let's back up. How you knew that, you didn't write this on your paper because you were smart enough not to need to. But that's what your brain saw. Your brain saw, oh, I'm going up by 3 every time. So I'll go up by 3 again and up by 3 again. And what that's called, and what makes this an arithmetic sequence, is a common difference. The difference between any 2 terms, at least 2 terms that are next to each other, is common. The difference is always 3 in this particular series. And when we get to formulas, we'll use a D to represent the common difference. All right, A sub n, that represents the nth term. So we're counting these, first term, second term, and so on. So the nth term for this sequence is, let's just start with 4, and then we'll add on to that. And we're going to add 3 each time. But here's where we need to be a little bit careful. For the first term is 4. How many times do I need to add 3 for the first term? A few of you are shaking your head like, well, you don't. Yeah, the first term I don't need to add any 3's to. The second term I need to add 1 3. The third term I need to add 2 3's. The fourth term I need to add 3 3's. So I'll need to add like 1 less 3 for each term that I'm on. So that's where the n minus 1 comes in. If you're on the second term, you need to add 1 3. If you're on the 100th term, you need to add 99 3's. If you're on the 1000th term, you need to add 999 3's. So first term plus the difference times however many steps away you are. Let's write that more generally so that we can box one up and use it for all the arithmetic sequences. First term plus the common difference times n minus 1. So that's our explicit formula for arithmetic sequences. That'll get you to any term you want. If you know the first term and the common difference and what term you're headed for, you can figure out the 57th term or the 900th term or whichever term you want. You can also just count up, you could just label them. This is the first term, the second term, the third term, and so on. And what we usually like to do on the test is, on a couple places, ask you for the 573rd term or whatever, to force you into using this formula rather than you writing out. And occasionally people do it, like they forget the formula. Shouldn't be a problem this year because you have the formula, or they want to check, and so they write out 573 blanks and fill them all in. I mean, hey, it gets there. The formula is a lot easier. And again, we'll try to ask for some way out there terms to force you into the formula to keep you from just, if we ask for the 7th term, you're just going to count out and get the 7th term. And that would be fine, but we'll ask for some way out there terms. All right, so arithmetic has a common difference. You're just adding 3 every time. Common difference could be negative, so you could go down 3 or down 5 or whatever every time. The second type is geometric. So something like, let's make that 1/3. 1/3, comma 2/3, comma 4/3, comma 8/3. And again, even before this lesson, I could have shown that, I could have made that a warm-up without saying anything, and I feel pretty certain that all of you would know what comes next. What goes in the next blank? Maybe my certainty was misplaced. 16/3. And the next blank? 32/3. How did you know that? What are we doing each time to each? Yeah, you're multiplying by 2. You're multiplying by 2 each time. In fact, the ratio, so not the difference, last time it was the difference, this time it's the ratio, the common ratio is R. So if we multiply by something each time, that's geometric. If we add something each time, That's arithmetic. See if we can follow. It's a similar pattern to that last formula. If we want the nth term, we'll start with the first term. But we're not adding a bunch, we're multiplying a bunch. And we're multiplying by r. But I need to multiply multiple times. If I want to get to the 10th term, I need to multiply by r 9 times. Right? It's still that one less thing. So the first term, I don't need to multiply by any r's. After that, I need to start multiplying by more and more r's. What kind of math, kind of operation do I need to do that makes me multiply by something more than once? I don't know if I asked that question right. Exponents. So if I have an exponent, that tells me how many times to multiply by r. Right? R squared means r times r. R cubed means r times r times r, and so on. So r to the n minus 1 means multiply by r n minus 1 times. So even to a ninth grader, maybe they would look at those and say those formulas are very different. Those aren't the same. But we know more now, and so we look at those and we say, yeah, they're different, but they both start at A1. Arithmetic we're adding, geometric we're multiplying. Arithmetic has a common difference, geometric has a common ratio, and we do that n minus 1 times. So there's some similarities between the two formulas. Again, you'll have the two formulas, so it shouldn't be difficult to keep them straight. And then the last type would be neither. So if it doesn't fit either of the first two types, sometimes these are a little bit harder to recognize because you're not multiplying by the same thing each time or adding the same thing each time. So these really are more about just recognizing patterns. Yeah, 25 and 36. Those are just the perfect squares. But it's not arithmetic because the common difference is, it's not a common difference. The difference is 3, 5, 7. That's not it. The ratio would be even worse. Multiply by 4, multiply by whatever that is. So it's not arithmetic. It's not geometric. It's just, do you recognize the pattern? So sometimes those are the worst because there's no set way to do them. You just have to recognize what's going on. All right, the type of questions we'll ask today are, is it arithmetic, geometric, or neither? And find the next three terms. So we kind of did it already, but we did it by section so you knew what the type was. 54, 18, 6. So the first question is it arithmetic, geometric, or neither? And then find the next three terms. Although I guess sometimes you could find the next three terms first. If you immediately recognize the pattern, you might fill it in and then figure out exactly what you did to get that. Does anybody see what's going on here? Divide by 3. Now, we didn't say that there was a divide by type. There's only a multiply and an add by type. So it's like multiplying by 1/3. I mean, if you say divide by 3, you're fine. You're still going to get the right answer. But if we're thinking geometric, let's see, that has a common ratio of 1/3. We're multiplying by 1/3. And we kind of just keep that idea. You don't have to label them, but some people do because it helps them get the next term. I mean, you just puts on paper what's already going on in your brain. 54 divided by 3 is 18. Divided by 3 is 6. Divided by 3 is 2. Divided by 3 is... Here's where switching to multiplication might be better. 2 times 1/3 would be 2/3. And 2/3 times 1/3 would be 2/9. And we said it was geometric because it has a common ratio. So, pattern recognition and then knowing the names for multiply means geometric, add means arithmetic. All right, this one looks a little different. Instead of giving you 3 terms, I'm just giving you the equation. And it doesn't exactly look like either of the equations we had earlier. So why don't we find the first 3 terms and then maybe figure out what's going on here? So A1 means plug in 1 for n. So the first term is 2. A2, plug in 2 for n for the second term. 5 minus 6 is negative 1. A3, plug in 3 for n. 5 minus 9 is negative 4. So it only asks for 3, so we'd be good to stop there if we recognize what's going on. But it's not a problem if you're like, oh, I'm not sure, let me check 1 more or 2 more to make sure. So I'll go 1 more just to kind of verify. I think I see what's happening, but 1 more will make sure. 5 minus 12 is negative 7. Now I feel pretty good. Is this arithmetic or geometric? Arithmetic. How did you know that? Right, good. Your common difference is negative 3 every time. It didn't ask for that, but you kind of had to know that to know it was arithmetic. That minus 3n, if we were really paying attention, that might have clued us in that we were subtracting 3 each time. Or like you guys said, add negative 3 each time. Now, I put more work on there. All you would have to say is, here's the first 3 terms, and it's arithmetic. Then you'd be done. All right, kind of like the last few times, Miss Morris has been awesome enough to collect all the worksheets at once so that I can give you a packet. You know, on day 1 it feels like, oh my gosh, what's he giving us? But it's the packet for the whole week and a half. For you guys online, it's uploaded, it's ready, so you can print them out all at once if you want, or you can print them out one at a time as we go, whatever works for you. But today's assignment is Unit 7, Worksheet 1, and if I get around to it, I'll post some odd answers online, but most of this worksheet's pretty easy, so you'll probably cruise through it in no time. So, assignment today, Unit 7, Worksheet 1, and if you haven't finished everything you need to finish, please get on that because it's got to be done by next Friday.